Hello friends, in today's question, water is filled up to height h in a beaker of radius r as shown in figure. The density of water is rho, surface tension of water is T, and the atmospheric pressure is P naught. Consider a vertical section ABCD of the water column through a diameter of the beaker. The force on the water on one side of this section by the water on other side of this section has the magnitude. So we have this beaker and there is a column ABCD inside the beaker, and we have to find out the force that is being exerted on this column by the other side. And the height of this column is given as h, and the diameter of the radius is r, so obviously the diameter of this water tank or beaker will be 2r. So in this case, there will be two types of forces that will be acting on this water column. One will be the surface tension and the other one will be the pressure force. So you can say force is exerted on one side of section by the other side. So there will be two forces. First one will be surface tension and second one will be pressure force. So let us first of all consider the first force that will be because of the surface tension, force due to surface tension. So we can define it as that it acts along the surface of the liquid and between the interface of the liquid and the air. So that at that point the surface tension force is going to act. We can say that surface tension is the force acting along the surface of the liquid, along the surface of the liquid at the interface, between the water and air. And we can say this force will be acting in the tangential direction. We can further state that this force acts tangentially to the surface of the liquid pulling the liquid molecules together. Pulling liquid molecules together. and it is also you can say given as per unit length and denoted by T. So you can say surface tension force per unit length is given by T. Surface tension force per unit length is given as T, where T is the surface tension coefficient. Where T is surface tension coefficient. Therefore, we can say that the total force that will be acting will be, you can say, depends upon the liquid surface that is in contact with the boundary of the beaker. So you can say from here, total force due to surface tension depends on the liquid surface in contact with the boundary of the beaker. And in this case, the beaker is given as a radius of R. So we can say for beaker of radius R, the length is 2R, as since we are considering a vertical section and that vertical section is across the diameter. Since we are considering a vertical section across its diameter, therefore the force due to surface tension let us say it is given as FST, and that is equal to its diameter multiplied by T. And this force acts horizontally pulling the liquid from left hand side to the right hand side. The force acts horizontally pulling the liquid from left hand side to right hand side. So we can just figuratively show how this. So this is our section, and the direction of surface tension, force rather, will be in this direction, and this is our total, and this section is given as A, B, C and D. So this is the force due to the surface tension. Now the second is force due to liquid pressure. Force due to liquid pressure. So we can consider a small, you can say, we have to find out the force due to liquid pressure on this entire ABCD. So we are going to consider, you can say, a small strip which is at a distance of x from AB, and find out what will be the pressure at that point, and then we are going to integrate for its entire height, and the height is given as h. So we say, so this is a small strip considered, and this is at a distance of x from AB, and total height is h. So we are going to find out what, and the thickness is dx. So we are going to find out what will be the pressure at this point, and then we are going to integrate for this entire strip from 0 to h. Okay. So you can say, and in this case also, on this strip there will be atmospheric pressure that is given as P0. So you can say the pressure at the depth x below the surface of the liquid pressure at the depth x below the surface of the liquid, which is water in this case, and let us suppose that is given as P of x. This will be P0 plus rho gx, and P0 is given as atmospheric pressure, rho is the density of water in this case, g is the acceleration due to gravity, acceleration due to gravity, and the total force is found out by integrating over the entire height of the liquid column, that is h. So we can say force due to liquid pressure is found by integrating the pressure over the height of the liquid column, over the height of liquid column, and height of the liquid column is given as h. Height of the liquid column, which is given as h. So let me redraw it again. So this is at a depth x, this is our A, B, C, D, and total this will be 2r along the diameter, and we assume that the total, you can say, pressure or small, you can say, value of the force that will be acting because of the pressure, because of the liquid pressure, let us suppose that is given as df and its thickness is given as dx. Okay, and we have a height in this direction. This will go p naught. Excuse me. So we can write at the depth, excuse me, at depth x, the width of the section is 2r. Therefore, small force because of the pressure P will be equal to Px multiplied by 2r into dx. So you can say this is our pressure and this is our area of the strip. So it comes as pressure into area, small area rather. So we can write total force Fp, total pressure force Fp will be equal to integrating 0 to h, and we have Px 2r dx. Substituting value of Px, we get this as 0 to h. This is P naught plus rho gx to r dx, taking 2r as common, so this becomes 0 to h. We have P naught dx plus integration 0 to h, and this will be rho gx dx. So now it is simple calculation. So this will be coming as 2r, and we have this one as P naught x plus this becomes rho g x square by 2, so it will be coming as h square by 2. So this is a total, we can say, pressure force acting on the surface tension, because of the liquid pressure. So now we are going to find out the net force on one side, net force on one side. So let me redraw once again. So this is our, so we have a surface tension Ft which is acting in this direction, and there will be a force Fp which is acting into the section. So this is our A, B, C and D. So therefore the net force exerted by the vertical section, the net force exerted by the liquid on one side of vertical section to the liquid on the other side, liquid on the other side. So let us call that F net. So F net will be equal to, this is FST. Okay. This will be equal to we have our FP minus FST. So we already know FP and FST. So FP was our 2R P naught H plus we have this as 2R rho G H square divided by 2 and minus 2R T. So in this case there are three terms. First term is atmospheric pressure. Second term is hydrostatic pressure. And third pressure is surface tension. And if we see the options available to us, we can clearly see, oh, I forgot to cancel out 2, so this 2 goes away. So the options available to us is our option number B. Okay, because this is 2 P naught RH plus R rho GH square minus 2 of RT. Okay. So option number B is the correct option. So you can say option B is correct. So this completes the question. Thank you.